No. I opened the wrong thing.
This is so fun. I know. Sorry.
Is that doing something? Yeah. Is that all right? Yes? Okay, folks, I apologize. There was a mistake in calculation in my part. So you had a roller coaster. Okay, so for some reason, for some people it was very good. For some other people it was not. But anyway, the disruption was my mistake and I apologize. Can I move on from there now? Okay. So from what I see, and I had a chance to see it from the other side. So from what I see, there was something wrong. What is wrong is that, you know, I gave you the homework, quite a bit of practice, and then it had the your hints. With the hints, you did the your homework nicely. But then in the quiz, some of you, I know this for a fact, opened up the homework and the quiz was very parallel, written deliberately like that, and opened up the homework and used the same process to answer the question, and the outcome was good in terms of grades, but learning was missing. So that's why when it came to the exam, some of you couldn't do it. That is my observation. I don't want to pin anybody down, but I know it for a fact, and I told you so that you know what not to do. Okay? If you learn it, that will help you. Ultimately, you will get caught up by somewhere, you know. So avoid this. I opened up the homework. You should do it all over again many times, as long as you are not comfortable doing it alone without him. Good. That is something I am telling you as a friend. That is something I'm telling you as a friend that will help you. Okay. So
Hello, Dr. Basu.
who is there?
Yevi.
Yevi, very good. Okay. Yevi, thank you very much for pointing out the thing. Did you do it, or is what it was the
I emailed you about the question with
yeah.
450.
It was good. Okay.
Thank you, Dr. Basu.
Okay. So I corrected it. No problem. Now the thing is, let me go over it one after another. Okay. I would do it all, and I would bring up the questions too for you. Okay, so that I'm not doing anything in vacuum. I would bring up the question, but you should understand what went wrong. How many are here? Let me see.
There's a few, but I think more people are joining, sir.
Okay, it's 101. Very good. So let me go. This is the exact question. I didn't change anything. Okay. So what is it? It is CP3 5 hours, and it is a bolus thing. If nothing else is given, it is a bolus thing. Okay, I would appreciate if you don't write down the question itself. You should write down everything. You should read from here. You should write down everything. That's fine. Okay, if you want to write down the question, I get to write more questions. That's all. Okay. So, you know, for learning, do whatever is necessary for learning. That's all. Okay. I would like to help. Okay. What is it? Concentration 5 hours after the third dose, right? Let's say CP 3 5 hour equals to CP 1 5 hour multiple dosing function equals to, in here, see, nothing else is given. It cannot be absorption because there is no absorption rate given. It has to be IV. If it is IV infusion, you need more information. It can only be bolus. Good. So write down the CP1 5 hour then. What is it? Dose over Vd e to the power minus, who is that? Hello? Oh, is that Roman? Okay, anyway. E to the power minus k t, that is 1 times multiple dosing function 1 minus e to the power minus n k tau 1 minus e to the power minus k tau. N is 3, tau is 6 hours, etc. etc. So main thing is not doing the calculation though. Do you have any confusion in setting it up?
No, not in this one, sir.
Okay. So let me see who else is in here. Can you show your faces? If you don't mind. I just don't want somebody to just open up the Zoom and go away. have a coffee break. Okay, so who else is here?
I'm here, Dr. Basu.
Bridget, okay. I'm sorry, Bridget. I mean, because of the mistake, your grades went down, but what you got is what you actually achieved, okay?
Hello,
Okay.
Dr. Basu. I'm here.
Who is that?
Valerie.
Okay, Valerie, good. Okay, awesome. Now we go back. So is there a problem understanding this one? Good. Should I move on? I don't need to do the calculations though. You understand that? Right? Is there a problem with this one? Did you think anything else of doing anything else? Oral could not be done. Infusion couldn't be done because there was no such, not enough information. Good?
Yeah.
Good?
So for this one, we know that it's an oral dose just because we rule out the other two, right?
We know that it is not oral because there is no absorption is given.
Oh, I mean that it's a bolus. I'm sorry. We know that it's a bolus because we rule out oral and infusion.
Infusion, because in infusion you have to have the infusion rate. There is no infusion rate given. Good?
Okay. Yes.
Anything else that you want to do on this one?
And the towel is every 8 hours, correct?
No, it is, oh, it is 8 hours. So, sorry, what did I get 6?
I think it was the half-life,
Oh,
maybe
okay.
it's 6.
Oh,
That's
sorry,
okay.
sorry. Yeah, right. Good, folks. Or do you want to go and do the calculation? Good? Okay, fine. Next question. %71%, etc., etc. What is it? What is the question now?
Yes.
Hepatic elimination rate constant KH, right? To do that, you have to get K first. Good. So K is equal to or let's say slope equals to negative K equals to ln of the last. Let's do the last two. 1.03 minus 2.27, and then what? 12 minus 8, and etc. etc. You get a K. Good? And then it said what 71% of the drug is eliminated unchanged through urine. That means KR is 0.71, right? Sorry. Now, effort fraction or through urine is 0.71. So FH equals to 1 minus FR equals to 1 minus 0.71 equals to 0.29. So KH equals to good?
Yes.
Good or not? Now the thing is, so 0.29 and then whatever it is in there, multiply. Good? Now that is, I thought, was a very straightforward question, right? Is it difficult? Now the answer is 64% right in here, right? So that tells me that there was not enough practice, nothing else. There is not enough practice. This one is not tricky, not difficult, nothing, right? You have to calculate K and then calculate hepatic FH, right? Fraction hepatic. Whatever I gave, That's not what I asked. I gave you the renal fraction. You got to get the hepatic fraction and then multiply. Good? Good with this one, folks? So all these things are given. Okay, now the thing is you have to do the CP naught. If you go through the equation, ln Cp equals to ln Cp naught minus Kt. Now K comes from the slope. So slope equals to negative K equals to ln of 1.03 minus ln of 2.27, no, 27 over 12 minus 8. Let's do it. How much is K? 0.198. Now, so the equation becomes ln Cp equals to ln Cp naught minus 0.198 T. So you have so many T's and concentrations, just plug one in and then you should get ln Cp naught, and ln Cp naught equals to ln Cp plus, sorry, 0.198 T, and then from there take the anti-log. One mistake I made is I should have had all the quizzes in the class in a proctored environment. I just trusted you as adults. So good, folks. You want to do the calculation? Go ahead, do the calculation. It's okay. Otherwise, Cp naught equals to e to the power, etc. Okay, so take the anti-log of it. That's Cp naught. That is the starting concentration after IV bolus dose is given. Good? Conversations. So y'all are just depressed and you look pretty beaten up. By the exam or something happened at home. Conversations and situations when we're in relationships. So I do have a dentistry friend that has always been my friend. Okay. We have discussions about things. Like, have you all ever been intimate? No. Ever. So you're telling me you came you drove for half an hour. Yes, conversation. And you giggled and you thought it was fun. Yes. You drove for how long? But you had a problem with that, right? Because what's dangerous can be an issue. Okay. I changed the grain. That's my mistake, but you know what? I every day drive for. Did you express that to Mrs. Trump? I don't know. Okay. Anyway, good. We are good till now. Well, are we good?
I think someone's mic's on.
Somebody's mic is on. Yeah, I can't hear you over it.
Yeah, if you want to have a conversation going, then I have to mute you. It's your choice.
Thank you, that's better.
I mean, you know, if you have a conversation going on when only I am on the other end, it's okay. But the thing is, you know, I am also doing the same thing with face-to-face students, okay? So if you want to have a conversation going, do it over chat. However, that, will that work? Okay. Anyway, so apparently it is working. Okay, good. Should we move on?
Yes, sir.
Okay, good, Bridget. Okay. What is it? Assume that the drug follows one control. Is that the same question?
Yes, sir, it is the same question.
Yeah, that's the one. we
Yeah,
just
so
had.
then we don't need to do it. Okay. I manually copied, so I might have copied 2 times. What is the volume of distribution, etc.? Now, the volume of distribution question comes. Where can you find the volume of distribution? One time point when you have the amount of drug in the body and the concentration, both, that is Cp naught times 0. At time 0, you have the whole dose in your body. At time 0, you have the whole dose at your in your body, and then you also have the instantaneous concentration. Do you understand? So dose over Cp naught will be your volume of distribution. In other words, dose, drug in the body, or dose equals to Cp naught times volume of distribution, Vd, equals to dose over Cp naught. Now that Cp naught, it's the same question, but it's not related. If you don't recognize that it is the same question, you do the Cp naught again. Good, folks? So that particular question, it is actually it's not volume of distribution, it's not bad. 86% got it right. Okay. Now you get Paris Hilton. Okay. For the particular patient, if the maximum possible dosing interval is that. So if the maximum possible dosing interval is that, then your practical tau is 24 hours, right? Good?
Yes, sir.
Infused over a time of half hour. Okay, so all of these half hour, all of these are given. So what you have to do is you have to get the K0. Everything else is being given. It is T infusion is equal to half hour. Okay. And then volume of distribution Vd equals to 0.275 times 75, etc., etc. And then half-life, T half is 8 hours, so K equals to 0.693 over 8. Right? So if that is the case, then you could say Cp steady state max equals to Cp1 max times steady state function Cp1 max, if you are doing an IV infusion, that is K0 over K Vd 1 minus e to the power minus K T infusion, that is 0.5 hour here. That is the max. And then you have steady state from 1 over 1 minus e to the power minus K tau, etc. What we are doing here is this. This is the first dose. But we are not bothered about these things. We are doing it by the max. Max is when the infusion stops, right? Good. Here, we don't have to worry about the any point here because we are not calculating any point in the falling phase. We are calculating on the top, and then your multiple or steady state functions take me from top of the first dose max CP1 max to CP steady state max. Now CP steady state max is not the unknown. The unknown is K0. So CP steady state max, etc. And then you have the therapeutic window, right? This therapeutic window 10 microgram per ml equals to 10 milligram per liter. 10 microgram per ml is 10 milligram per liter. So that is 10. This is the only unknown. Okay. K VD, K comes from here and VD comes from here. Okay, T infusion is 0.5 and tau is 24 hour, etc. etc. So now the thing is, can you tell me where is the confusion here?
My confusion was the units.
Yeah, me too, because we were working with milligrams over liters, and that's where I went wrong instead of putting
Okay,
over
fine.
hours.
Yeah, microgram per ml is milligram per liter. If you multiply both the units, okay, on numerator and denominator by 1000, then you are okay, right? Because 1000 cancels out. Microgram times 1000 is milligram. Good.
I think I was able to do that, sir, to get to the milligrams over liters, but the
Same.
final answer was milligrams over hours. And I stuck with milligrams over liters, so I got half of that one wrong because of the units.
Okay. Good suggestion. That is, if you are stuck writing the units, then the right units of everything. Then units will cancel out. If you don't write the units, I say, Messi, I say. Okay, if you don't write the units, then other way is K0 is the dosing rate, that is mass per unit time. In this case, the unit should be milligram per hour, Messi.
Yeah, that was my mistake. I mean, there was a lot to write, even if I did put all the units down, that whiteboard gets pretty messy.
Yeah.
Okay, the solution to that is write very small and write very nice.
I will
don't
That's a
know
good
how
point.
else I can solve it. Used to be a paper test where you can get unlimited papers, but that is beyond my pay scale. Okay,
That was my generation, sir. So
good. Moving on. Yes. Because 24.5 is the maximum possible tau. What is it dependent upon? A therapeutic window. So from here to here, it cannot be more than 24.5. Now, if you want to give somebody a dosing regimen with 24.5 hours, every day it is 5 hours, half an hour later, you want to give that? So you have your answer, right? Today is it at 4, then tomorrow at 4:30, the day after at 5, it will not work though, right? You understand now? Yeah. So you maximum, whatever is the maximum possible tau, you have to come down from there. You cannot go beyond that, right? and come down to how much? Not any number. Only 4 numbers are possible. Like 24, 12, 8, 6. Done. Good. So, folks, are you okay with this one? Are you
Yes,
okay
sir.
with this one, Ola?
Yes.
Good. Are you okay with this one?
Yes.
What is
Yes.
so funny?
Yes.
We're talking. We're having a good time.
A good time? Okay. Have a good time. Have a good time, folks. Now, so this is, and you want to know the story. 18% correct in this one. Everyone tells me that the very purpose why I did so much work, homework and tests and whatnot, that was defeated. And if you want to know, the online students who have a little less confidence because they are far away, okay, they actually did better than the face-to-face students. A little, because they are a little more scared. That's all. Seriously, I'm not joking. I'm not joking, seriously. Anyway, next question. Yeah, anything you want to mention? Something? Okay. So what is the question here? What will be the dosing rate K0 in a constant intravenous infusion, etc., etc.? Okay. So what is it? If you draw a picture, it actually doesn't take that much time. If you draw a picture, constant constant infusion, right? Intravenous infusion, no stopping, no starting, nothing, constant. That means you are getting at steady state. So after this point, you are at CP steady state. So CP steady state equals to K0 over KVD. Now, all these you have to probably figure out from here. Okay. So this piece of information you don't need. Half-life is 3 hours. So K equals to 0.693 over 3 equals to 0.231, 1 over hour, I think. And then CP steady state is 50 microgram per ml, milligram per liter, etc. See, it is said concentration is to be maintained for a long time, etc., etc. And then VD is to 0.2 liter per kilogram times how many? 70 kilogram equals to 0.3, no, how much? 14. Sorry. So 14 liters. That is the thing that VD. That is the thing that I was mentioning a few minutes early. If you write the write units of everything and then let it cancel out, or write the units corresponding to what you are calculating. VD has to be a volume liter. There is no other choice. Okay. K0 is dosing rate milligram per mass per unit time. That is one approach. Or if you have the patience, then write down every unit, let it cancel out. Whatever remains is your unit. Good. These two, any one will work. Good. So K0 equals to what? CP steady state times K times VD. And then the plugging part you could do. Good. So it is actually very simple. Yes.
So how come for this one we wouldn't attach the accrual to it?
Okay. Yes, good question. Accrual. Accrual comes when? Accrual by definition comes when? Steady state, but accrual is, can you, what is the equation for accrual? If I ask you, how much is the accrual, what do you do?
You want the equation?
Yes,
It's 1/1 minus e to the negative k times tau.
good. So tau is what?
This tau wasn't given in this.
Tau is what? What is tau? It is hour, I know,
Yeah.
but what is it? What is it? Think about it, it will be very clear to you. What is tau? Tau is dosing interval, right? Now dosing, what is the dosing interval in continuous dosing? It never stops. So the question of accrual doesn't come in continuous infusion. It never stopped. Those accrual can also be seen as the ratio between the steady state concentration and fast dose concentration. Good. Steady state concentration at any time t, 3 hour, 5 hour, 8 hour, whatever, divided by fast dose concentration at the same time. Good. Now we never stop the dosing. So we are in fast dose itself. That is the only situation where you don't deal with accrual at all, because it is the same dose continuing. There is no ratio, no question of ratio. You understand? It's a good question. Okay. So next question is, what will be IV bolus loading dose? So those kind of things, loading dose. So if you can tell me the equation, what is loading dose? Loading dose equals to K0 over K equals to CP steady state times VD. Whichever one you have numbers, data with, you could use, you will reach the same point. Good. Loading dose is the question. Depends on what is the maximum concentration that you have to reach, you want to reach, right? What is the maximum concentration you want to reach, right? So that maximum concentration is given here, I think. Is to be achieved from the very beginning, 60 microgram per ml. That is the maximum, that is CP steady state. Good. It is indeed overwhelming if you don't practice quite a bit. There are so many equations which applies when. It is kind of overwhelming. It was same with me also when I was a student. But only remedy to that is to practice your without looking at the answers, hints, etc. Okay, practice. That's why. See, you got all your homework grades, etc. Whatever. I am not touching anything. Now all the homeworks are open. You could practice. You could practice as much as you want. Good. Don't make the mistake that you made before. Good. Then you will be fine. So good, folks. This problem. Anybody? Any comment? No. No. Okay. Let's try that. Let's try that. Okay. CP steady state is 60. VD is how much? 14. 840. Now this K0 you have to figure out now, because you want to do it this way, right? Okay. So if you want to reach CP steady state, okay, so CP steady state equals to K0 over KVD, right? Now, VD is 14, K is how much? Half-life 3 hours. So K equals to 0.69 693 over 3, 0.231, right? So you plug in all this 0.231 and CP steady state 60, and then you figure out K0, and then you use K0 over K. You can do it. It will be the same number. Same number, Lawrence. And why will you do all this fighting? You have the numbers in front of you. Why do you do all this fighting? Mr. Me, you want to say something?
Oh, my grade dropped 25%, so I'm a bit mad right now.
You're a bit mad.
Well, other
Okay,
grades
okay.
went up, so like, what's the fairness?
Okay. Yeah, but let me, okay. If I give you 25% back, you are not mad. Now can you learn? No. I am.
So 25% is a lot. It's not 5%. It's not 10%. It's literally 25%. And that was on. So like how?
No. 25%. What I gave you before was my mistake. Now there is no mistake involved.
It's because I read it as 14.21 because the leaders looked like a 1. So like that's why I got it wrong. Because I couldn't see it. Anyway, that was
That is kind of innovative. Okay, you know what?
no, that's genuinely I'm blind. I can't see it.
Really?
No, actually, no. I just have bad sight.
No. I had that situation before. So in that situation, what we are required to do is to make everything 14 font and higher. I could do that.
It's totally fine. Just misread it.
Okay, got it. You have one.
CP steady state. Okay, so you're assuming 60 is the steady state.
You should definitely read. You will do fine. That you are just very upset at me right now. Okay? You know, I am facing the crowd 2 years later, you will not even remember me. Forget me.
Oh, I think we'll all remember you.
No.
We'll all remember you.
Forget me.
Very,
You don't waste your emotional energy on me. Just do it again, you will be fine.
Ooh.
I tell you.
Okay.
I'm just a face in the crowd. Can we do it now?
For this one, I get 840, but what am I solving for? Like
That is
this
the,
way. Do you know what I
if
mean?
you solve for K0
Then I got.
and then you get K0 over K. So you are going
So I
over,
put this over K now.
yeah,
Okay.
you are going to Toledo, but in between you are going to Dayton and then your Detroit and then coming to Toledo.
So
Good?
is it okay if one's 843.6 and one's just 840?
Yeah, right. Yes, it doesn't matter. You know, but the thing is, in real life, if you write the equation in real life, you will never do it like this because it is the easiest thing to do. Okay, here CP steady state max is the question. This is the question where I actually made a mistake. That is, it is a 450 milligram dose given over 2 hours. So K0 is 450 by 2. That's where I missed it first time around. Okay, that was the mistake. Okay, so K0 equals to dose over T infusion equals to 450 by 2 equals to 225 milligram per hour. That is K0. That is where I missed it. Good. After you know this, after this, there's a situation is kind of very easy. And believe it or not, this mistake you are pointed out by a student. Okay, so somebody is doing his or her work. Good. What will be the steady state maximum concentration? So Cp steady state max equals to Cp1 max steady state function. Now this one being an IV intermittent infusion, so K0 over K Vd 1 minus e to the power minus k T infusion, that is Cp1 max times 1 over 1 minus e to the power minus k tau. This T infusion is 2 hours. Okay, so elimination half-life. So K equals to 0.693 over 2.8. That is what it is, 1 over hour. So here you have everything that you would possibly need. Okay, Vd equals to what? 0.65 times 70 kg, etc. And folks, we have done it so many times. It might be a lack of practice, but I don't know what else. Cp steady state max, Cp1 max times steady state function. And then you are in IV intermittent infusion, so you have to use the intermittent equation. Now here, since we are doing max, you don't have the falling phase. You don't need to add the e to the power minus k, t minus t infusion. That part is not here at all. Good. If I ask you what is the concentration 7 hours after the dose in steady state, then you would have another part here. That is the falling phase, right? E to the power minus k, t minus t infusion. That is what you would have had. So folks online, do you have a question? Are you here?
Yes, but no question.
No question?
Or did you have?
No questions here.
Okay. No, I just want to make sure that you are also being addressed. Okay, folks? Good? You want to say something?
If you use the 225 for the K0, is your C infusion just 1 hour then?
No.
I was.
I tell you what. So what is your question statement? You are giving the dose is 450 milligram. So you have to give 450 milligram, right? So if you give 1 hour, then you are giving 225 milligram. That's the dose, right? But you have to give 450 milligram. That's why 450 milligram given over 2 hours. Good? You understand? So generally, we actually did one problem with half an hour, I think, right? But whatever it is, total dose divided by the time to give the dose gives you the hourly dose, right? You understand what I'm saying?
Yeah.
So if you are given 30 minutes, then it is, then you have to still convert it to hour.
So regardless, you have to find your K0 just being 1 hour and then whatever your time.
Yeah,
is,
right.
you still
K0 is the
consider that
dosing
routine.
rate, dose over time of dosing, that is dose over T infusion, right?
Yeah.
K0 is not the dose. K0 is the dosing rate. Good? Folks, any question? Should I move on? Here, the thing is, here also, this 3 questions at a stretch, one after another, that has the same supposition that, okay, you have 450 milligrams, etc., etc. So rifampicin in intravenously over 2 hours. Here also, I missed the 450 2 hours, so that's why your my calculation came to 16 point something, whatever that is above the therapeutic window. Therapeutic window is up to 10.5 to 10. So your if you do it, it will come to 8 point something, 2, 3 or whatever. So that is both safe, and then if you do the minimum, it is effective also. Based on this, what you have to do is CP steady state max and CP steady state mean. These two you have to calculate, right? CP steady state max will be what? K0 over K Vd 1 minus e to the power minus K T infusion 1 over 1 minus e to the power minus K tau. That is steady state max. That is taking care of your maximum concentration. And that has to be below 10, right? Below 10. And CP steady state mean is a little more complex, K0 over KVD, 1 minus e to the power minus KT infusion. That is max. Now e to the power minus K tau minus T infusion. That is the falling phase. Good? Then you have 1 over 1 minus e to the power minus K tau. That is the same steady state function. That is the same steady state function. This number has to be more than 0.5 and this number has to be less than 10. That is the therapeutic good. Good, folks? Now, do you remember what went wrong? Why you had trouble if you did? Not everybody had trouble with this. Do you remember? What was the problem? This 2 hour thing?
It affected all of them.
Yeah, yeah.
Yeah, that's why.
Yeah, right. I'm sorry. Okay. I am sorry, but good news is I'm just giving you what went wrong. Next time it will be fine. I tell you. Next time, try it. Next time it will be fine. Okay. For a couple of more weeks. Okay. Just don't waste your emotional energy for a couple of more weeks. After that, you know, you will be P2. Who cares about Dr. Basu, right? Anyway, I'm giving you the best advice for you. Okay, that will help you. Okay. What is the concentration 7 hours after the commencement of the infusion in the 5th dose, etc., etc.? Looks like I need to give you more oral problems next time. I don't know. No? Okay. So 7 hours after the 5th dose, CP 5, 7 hour equals to CP 1, 7 hour times multiple dosing function equals to what? Intravenously. Okay, so K0 over K VD 1 minus e to the power minus K T infusion. That is the end of 2nd hour. That is the end of, up to now we came to the end of the dose infusion, right? Now after that infusion is stopped. So e to the power minus K 7 T minus T infusion, that is 7, that T infusion is 2, and then multiple dosing function 1 minus e to the power minus N K tau, 1 minus e to the power minus K tau. N is how much? 5. Good, folks. Good. That one also, it is surprisingly very low thing, you know, 36%, I think. Okay.
So here for our KO, we have to solve it again, doing the 450 divided by 2.
Yes, ma'am. If it is says over 2 hours, that is what it is.
Okay.
You know, the same thing. If it is say whatever hours it is given, that is has to be followed, right? So anywhere, anytime it is given over 2 hour, 3 hour, 4 hour, you have to divide by that time, dose by that time to get K0. K0 is K0 dosing rate equals to dose over T infusion. Good? Good?
Yes.
Okay. So folks, does it make sense? This one? Okay. So what is it? What is it? What is it? What is the question?
I think you need to move the chart down, sir, so we can see it. In 22, that one. It's asking for Tmax.
Okay, Tmax. How do you get Tmax? Oral Tmax.
Is ln of Ka divided by K over Ka minus K.
You know, my son also does that all the time. You start, how do you start with the right side of the equation? What is it, the left side? Well, you said what? ln over Ka over K over Ka minus K. So how do you start on the right side of the equation without defining the left side? What is it equal to?
Tmax equals.
Okay. When you don't have an equation, equal sign, then it is not an equation, it is an expression. Do you understand?
Yes, sir.
So now the thing is this. Anytime oral concentrations are given, okay, so you have to look at the terminal phase. You have to look at the terminal phase for K or K or whatever, okay. If you have to get it from there, okay, then the absorption rate constant. Absorption rate constant, that is Ka is given 1.51 over hour. How do you get K? That you have to get. It is also given that Ka is bigger than K. It is said that Ka is bigger than K. So terminal phase slope will give you what? Terminal phase slope in oral absorption will give you what?
I apparently don't know this one because I got it wrong because I used the first and the last data points like you had mentioned to look for K.
Well, you still have, we still
32.
have 80 plus students.
Oh, I can't see them.
Okay, anyway. What is the terminal? What does the terminal slope represent in oral absorption if Ka is bigger than K?
The falling phase?
Falling phase, yes. What is terminal slope? What does terminal slope give you if Ka is bigger than K in oral absorption? No.
I'm not sure. I remember going over it in class because you drew like the little line under what the slope actually is. Because it's like approximated close to it, but it's not exactly what it is, but beyond that.
Okay. Terminal phase, when Ka is bigger than K, terminal phase slope gives you K. When Ka is smaller than K, terminal phase, the profile looks like an undulating thing, then terminal slope is Ka. In this particular case, I said Ka is bigger than K, so terminal slope will give you K, that elimination rate constant, and to use that thing, you have to take the last two data points.
I don't
Last
recall going
two,
over that.
just to make sure that you are in terminal phase. Good. Use
I
the
get it
last.
now,
What?
but I get it now, but I don't recall ever going over that with you. Because I only recall you saying to use the first and last data points to find K.
That is for IV bolus, okay? Now the thing is, the way it is set up, I get to teach you nothing because everything is online and I don't have a class with online students. Only thing I do is to address any question. If you didn't ask, I didn't tell you. I could not teach you. I could not even upload the class videos to you anymore. Remember, I had to stop it.
Well, yes, but how would I have known that that's K terminal?
Because that comes from reading the material.
Where was it? Because I try my best to be as extensive as possible and I didn't see it anywhere.
Okay, sorry, it is there. Okay. But I mean, see, I would love to help you, okay? I would love to help you, but I could not teach you. It is an asynchronous system, and I was not allowed. We were advised not to upload class videos. I did for up to 10th week. 11th and 12th, remember, I did not because I could not.
And I know
Okay?
it's not you, sir, but whoever's advising you doesn't know shit.
I would
It's
stay
not you
out
because
of
you're
this.
helping us. You're helping us. You were
Come
uploading
on.
videos.
Okay. Okay. You said your thing. You expressed yourself eloquently, but I have to stay out of it. Okay. So you have to say these things in appropriate places, in appropriate language. Okay. Let me stay out of this. Okay.
I know it's not you, sir, because you were uploading videos. And like I said, whoever's telling you doesn't know better because they were helping. And I
I
will
want
express
you.
myself where it needs to
Okay.
be expressed.
Yeah, wait. I want you to stop right here and then make your observations in right place, in right language. But because we are trying to learn now, okay? So this is not very helpful. I'm sorry. This
Hey,
is
I have a question though.
yes. Now we are talking.
Okay, so you said that if we're trying to find the T max and if the KA is larger than K, which you told us, then we use the last two data points. So what if it was flipped? What if you told us K
Okay.
is bigger than
Yes.
KA?
I understand. Okay. I understand. Now the thing is, if K is indeed bigger than K, then your terminal phase will give you Ka. Right? Now, how do you get K? Is that the question?
Right. Like in that situation, would you give us K and tell us to find KA?
Okay. Let me first give you a general answer. That is, in that situation, you will have to do method of residuals. In the restricted context of your exam and this course, I would have to give you the KA because I cannot ask you to do method of residuals in the exam. So for your purpose in the course, I have to give you if that is the flip-flop is what I give. Otherwise, you would go and enjoy your method of residuals to get K. Good?
Okay. So just use the last two data points to find K.
It is to find K, but last two data points to find any terminal phase slope, you have to make sure that you are in terminal phase. And last two data point is the easiest because you are not taking any risk. If that last two data points are not in terminal phase, then it is on Dr. Basu.
Okay. All right. Now, I was just making sure, just trying to make sure I understood correctly.
Good.
Thank you.
Awesome. Anything else? Folks, anything else? Okay, so then let me finish this conversation with a same monotonous monologue that is, it will still work. It will still work. Just do the homework many times. Do it from your understanding. Don't copy anything. Never copy anything. Never follow anybody blindly. Anybody. If you don't know why you are going in that direction, don't go, stop. Good? Okay, thank you very much. Thank you. Okay, Bridget, just work, it will work out. Good?
Yeah. What?
Just do the homeworks again, it will work out. Take it again, it will work out. Don't worry too much.
Okay. Thank you. I will. I'll keep going over it. And you did a recording that I will rewatch too.
This one is recorded, yes.
All right.
Okay.
Thank you.
Okay, thank you. Take care, bye.
Thank you.
Bye.
Dr. Basu,
Yes.
so would you be able to send us maybe another question that deals with the terminal phase equation? Because looking at the homeworks, we never had a question like that. So I just want to know if you could send us like maybe a practice so that if you're gonna, like if it's gonna be on the final, I would like to practice it. Because I know that the information is there, but we wanna
Okay, okay, so I shall upload some
Okay,
worked out example of oral absorption dealing with the terminal phase, okay?
yes, that would be great.
Worked out example in PDF, okay?
Okay, worked out. And also well, I guess I could just copy and paste it because I just want to, I do these problems like so many times.
Just write it down, copy paste, do something, okay? Worked out
Okay.
example of oral absorption.
Okay,
I
that
shall
would be great.
upload 1 or 2, okay?
Yes, thank you.
Are we done? I'm
Yeah,
assuming.
I think we are
Okay.
done. Okay?
Thank you, Dr. Basu.
Okay, thank you. Bye.
Bye.